Alright, so today in 9.5b we're talking about complex fractions. A complex fraction is a fraction that has a fraction in its numerator or denominator or both. Examples are things like this, where you'll see a fraction in a fraction. You'll see a fraction in a fraction. You'll see multiple fractions in a fractions. By the way, this is harder than what you will get today. Now, here's the thing. You can't have fractions and fractions, just like you can't have decimals and fractions. And so we need to get rid of them, okay? So, no fractions. So remember, cannot be fractions or decimals in fractions. This is like a math law. Can't go against the law. We'll get arrested. So, to make all complex fractions simple, multiply every term by every denominator in the problem, which, by the way, is the common denominator. We've had to do this a lot, so this shouldn't be that crazy difficult, okay? When terms repeat, use the term only once, okay? So, here, I see a denominator of a, I see a denominator of 3. So we are going to times everything by 3 and a, both the top and the bottom. So if you think about it, this is one long fraction bar. I'm multiplying tops of tops and bottoms of bottoms. So it might help to put it over 1. So you realize that you're doing the tops of the tops and the bottoms of the bottoms. Okay? So I'm going to multiply across here, and I'm going to get 6a over a, because a times 1. I'm going to get 3ab over 3. And what happens here is you can cancel out your a's, you can cancel out your 3's. On top I'm left with just 6. On bottom I'm left with ab. And sure enough, that is the solution. I'm going to show you in class that this specific problem, and you can't really do that on any of these other ones, but when there's no pluses or minuses, you can just keep it, change it, flip it, and look, I'll get the answer even quicker. Okay? Again, not going to ask you to do that. Let's look at number 2. What is the common denominator for number 2? Well, I see an x and I see a y. So I'm going to times everything by x, y on top and on bottom. Now again, sometimes it's helpful to put this over 1, especially when you're dealing with fractions. So what I'm doing is I'm distributing this into both of these. So I'm going to get xy over x, again top 1 times that and x times that, plus 3 times that is just 3 times x, y, over 5 times the top, 5xy, over y, plus 4xy. Here we can see these cancel, here we can see these cancel. I have no more fractions and fractions. Y plus 3xy over 5x plus 4xy. And what students want to do now is they want to cancel out these xy's. We can't do that. This, by the way, is your final answer. The only way you can simplify this is if there isn't something in every single term. Y, nope. X, nope. Numbers don't work. That's as simplified as possible. Okay? So when I get the denominators, x times y gives me xy. So here, 4 times 5 gives me 20. So I'm going to multiply the top by 20. I'm going to multiply the bottom by 20. Okay? And again, this might be easier if you think of it as 20 over 1. But I know 1 times 20 is just 20. 20 over 4. 2 times 20 is 40 minus 60 over 5. Now I don't care if you want to use a calculator here, but 20 divided by 4 is 5. And 60 divided by 5 is 12. So I get 15 over 28. And that is the final answer. If I were to do this a different way, 1 minus a fourth is 3/4. 2 minus 3/5, 2 is 10/5, minus 3/5 is 7/5. We would keep it, change it, flip it, and I get 15 over 28. I'm not asking you to do it that way. I'm asking you to use the common denominator. This next one, super easy. If you realize they have the same denominator, we're just going to multiply everything by x plus y. Oh, x plus y, like that. Again, this is like one long fraction bar. So this common factors would cancel to give me 2. These common factors would cancel to give me 5. And that's it for that one. Okay? We're not even going to look at 8. That's gross. Okay? But we can do the rest of these. What's the common denominator for number 5? Hopefully at this point you can recognize I see x, I see y, I see it repeat. We don't write it more than once if it repeats. We said that up here at the top. So I'm going to multiply by xy over 1 into everything, and xy over 1 into everything. And again, I'm doing that because I want you to realize tops of tops, bottoms of bottoms. So into this first term, 1 times xy is 1xy, x times 1 is x, minus 1 times xy is xy, 1 times y is y, all over. 2 times xy is 2xy over y, minus 1 times xy is xy over x. They cancel, they cancel, they cancel, they cancel. I have no more fractions in fractions. Y minus x over 2x minus y. There's my answer. What's the denominator number 6? There's only one. It's x minus 4. It repeats. So I'm going to do x minus 4 on top over 1 and x minus 4 over 1 on bottom. But I have to distribute it. Here, this is again one long fraction bar because tops times tops and bottom times bottom. Don't distribute it. I got an x minus 4 that cancels to give me a simple 3 on top. On bottom, again, this is x minus 4 times 1, which is 1 times x minus 4. Minus, and this is kind of a longer parentheses. So that's this. Now I got to look at it here. I've got the minus already taken care of. 2 times x minus 4 over x minus 4. Now I'm kind of doing this intentionally. I don't want to distribute it because I want to cancel the x minus 4's. The 1 gets distributed. I have 3 over x minus 4 minus 2. That's what's left here. Well, I can simplify that and get 3 over x minus 6. And that is the final answer for that problem. Okay? The next one, what's the denominator? You see only one denominator. It's x minus 2. Okay, so x minus 2 is going to get distributed through everything. Distributed here is 3 times x minus 2 over x minus 2 minus 5 times x minus 2 all over 2 times x minus 2 minus 4 times x minus 2 over x minus 2. Those cancel. Those cancel. On top I get 3 minus, we're going to distribute this negative 5 into each term, 5x plus 10 over, distribute the 2, 2x minus 2 minus 4. And now I just simplify my like terms. 3 and 10 is 13 over, I can combine those two, 2x minus 6. Okay, what did I do wrong? I did something wrong here. Oh, 2 times 2, by the way, is 4 here. So 4 and 4 gives me 8. Sorry. Just looking at my other answer and I knew that I had something incorrect. So I just got to make sure I distribute the 2 into every term. Yeah, I was just trying to fool you. Anyways, that's it. That's the notes. Okay? The next page is your homework. The top 3 should look like what we just got done with, so that should just be a review. And then the rest of these problems, try and find the denominators. Look, here you're going to have AB because A is already there, so AB is what you need. XY, 15, x minus y, 2x plus 1, x plus 2. All the way down at the bottom here, xy, x minus 1, and x plus 5. Nothing here should really throw you off, nothing that hard. You don't want to see number 8. It's really gross. Well, you know what? If you really want to see it here, you can see what I did in number 8. Yeah, gross. Anyways, nothing's going to be that hard on the homework anyway. It's all going to be very similar to 1 through 7. Use these notes, flip back and forth, do what you got to do to be able to see what I did on these problems. Have a good day.